Okay, let's dive right into day 8 of our Masterclass Explainer. Welcome back, everyone. Today, we're crossing that critical bridge from beginner data science into serious production-level engineering. We are going to take your basic, out-of-the-box algorithms and completely transform them into Kaggle-winning, production-ready models. And how exactly do we do that? Through the absolute magic of hyperparameter tuning. Let's get into it. So here's our roadmap for today. Number 1, why tuning matters. Number 2, GridSearchCV. Number 3, Optuna. Number 4, production reality. Number 5, the business impact. And we'll wrap up with a mini challenge. Section 1, why tuning matters and the Ferrari analogy. Look, you've already trained an XGBoost model, right? But why pick a learning rate of 0.1? Intuition is totally fine when you're just exploring, but for actual deployment, no chance. Just relying on default parameters is literally like buying a Ferrari but never bothering to tune the engine. Right? Yaha jugad se kaam nahi chalega. Relying on simple hacks just won't work here. You have to fine-tune that engine if you actually want to win the race. Think of these parameters as neon animated sliders on a massive control board. These are the critical dials you absolutely must adjust. You've got the learning rate, the max depth of your trees, the number of estimators, and your subsample ratio. The base algorithm alone just isn't enough anymore. Precision tuning these specific dials is where the real data science magic happens. Moving on to Section 2, GridSearchCV, an exhaustive search strategy. Now, GridSearchCV is a sheer, unapologetic brute force approach. Watch closely how quickly the math explodes here. If you test just 3 values across 3 different parameters, that's 27 models. Multiply that by 5-fold cross-validation, that equals 135 massive CPU-burning training runs. It literally tries absolutely every single combination in that matrix. So you're probably wondering, when do we actually use this? Well, it's perfect for small grids, like under 50 combinations. It guarantees you check every single dark corner of your defined space. But more importantly, Agerbas audit mange, meaning if your stakeholders or managers demand a strict, reproducible, deterministic report of exactly what was tested, GridSearchIV is your absolute best friend. And hey, this perfectly illustrates a FANG-level coding trick. When you're writing your code, always set the parameter refit to true. Once the grid search finds the absolute best parameters, it automatically retrains a fresh model on your entire dataset. Boom, your best estimator is instantly production ready. And you just saved yourself a completely unnecessary extra training step. All right, Section 3, Optuna, a smarter Bayesian search. So what happens when your parameter space is just massive, and you simply cannot afford the compute power to try every single combination? Think of GridSearchCV as digging up an entire beach, literally inch by inch, just to find a coin. Optuna, on the other hand, is like deploying an AI drone that uses Bayesian Optimization as a treasure map. It builds a probabilistic model to hunt down the best metrics, focusing only on the most promising regions instead of just guessing blindly. Let's say you have a budget of 100 trials. Here is exactly how Optuna thinks. Pehle 10 trials bilkul random hote hain. Those first 10 trials are pure random exploration. But trials 11 and onwards, it actually learns from its history. It dynamically shifts from random exploration to hyper-focused refinement in those winning regions, which gives you vastly better results per compute hour. Keep this decision matrix locked in your head at all times. Use grid search for reproducibility and smaller spaces. But listen, you must switch to Optuna for tight Kaggle deadlines, large search spaces, and especially for continuous variables like learning rate, where setting some arbitrary grid just doesn't make any logical sense. The beautiful thing is, Optuna doesn't just tune, it explains. It generates these amazing built-in charts so you can visually track your optimization history over time. You can literally plot parameter importances to prove to your engineering team exactly which dials are driving the model's success. Just remember, 50 to 100 trials is usually plenty for small data before you hit diminishing returns. Section 4, production reality and avoiding the traps. Having all these powerful tools is great, but tuning is incredibly dangerous if you do it wrong. Dan Sisonol, listen to me very carefully on this one. If you tune your hyperparameters using your test data, it is literally an exam paper leak. You are leaking future information into your training phase. Sure, your metrics might look amazing on paper, but your model will completely and utterly fail in the real world.
To build a safe, production-grade pipeline, ekdam strict separation chahiye. You need strict, absolute separation. You train on your train set. You use your cross-validation folds exclusively for tuning your parameters. And your held-out test set? That is kept locked in a vault, used only one single time for your final performance check.
You've got to watch out for these absolute rookie traps. Number 1, never, ever use accuracy as a metric for imbalanced data. Use F1 or ROC-AUC. Otherwise, a 90-10 split will completely lie to you. Number 2, always lock your random state so your folds are actually comparable. And number 3, never treat your cross-validation score as the final word. CV is always optimistic. And here's a super quick mentor tip for your actual code. Always set the parameter n_jobs to -1. Grid searching is what engineers call an embarrassingly parallel task. Setting it to -1 unleashes all your machine's CPU cores at once. Matplotlib power you scuttle. Use all the hardware power you have to drastically speed up that grid search.
Section 5. Business impact. Translating those metrics to actual value. As a data scientist, you might geek out over Bayesian optimization, but let's be real, stakeholders only care about what your tuned model does for their wallet. Baisa bultahai, right? Money talks. Imagine taking a baseline XGBoost model with a 72% F1 score and pushing it to a massive 84% F1 score just by running a proper hyperparameter optimization pipeline using Optuna. That gap right there, that is your exact quantifiable value as an engineer.
So in your next interview or freelance pitch, you don't just sit there and say, I increase the F1 score. No, you translate it. You explain that this 12% jump means exactly this: a specific number of churned customers successfully caught, a massive chunk of company revenue saved, and an undeniable return on investment. Samajh rahe ho? Are you getting it? That is how you speak the business language.
Finally, Section 6, our mini challenge and the Day 8 wrap-up. Okay, we've covered the heavy tech and the business impact. Now it's time to test your engineering instincts. Here's your challenge for today. You run GridSearchCV. Your cross-validation F1 looks great at 79%, but your test F1 completely crashes to 62%. What exactly explains this massive gap? And what is your immediate next step as a data scientist? Think carefully about those overfitting traps we just discussed. Drop your thoughts and answers down below. Day 8 complete. Tomorrow we tackle advanced cross-validation strategies, so stay tuned, keep building, and I'll see you in the next explainer.